Hi students, good morning all. Our today's point is the dynamics of the circular motion, and it is the third point in the part first, because first point is the characteristics, second is kinematics, and the third is the dynamics. So write down part first, third point, dynamics. Dynamics of circular motion. Write down the dynamics of the circular motion. Let us see first what is the dynamics. The dynamics of the circular motion is the study of circular motion by considering the action of force on the particle performing circular motion. So write down the dynamics of the circular motion is the study of circular motion by considering action of force on the particle performing circular motion. And in this point, so write down, in this point we shall consider 2 points. We shall consider 2 points. Let us see first point, and it is a centripetal force. Part first, third main point, in which first point is centripetal force. Centripetal force. Now, before going to the centripetal force, let us see first why this point is after the centripetal acceleration. We know that every acceleration, suppose that this is a body, when I thrown it upward, I applied force, and so acceleration is produced. And it shows that every acceleration is due to the force. And from this knowledge, the centripetal force is due to the centripetal acceleration. So write down, as every acceleration write down as every acceleration is due to the force. As every acceleration is due to the force, so centripetal acceleration centripetal acceleration is due to centripetal force. We see first why this point arises after the centripetal acceleration. And the question will be asked on this point as, write down this question. What is a centripetal force? What is a centripetal? What is a centripetal force? Question mark. Now, the answer of this question is also expressed similarly like the answer of the centripetal acceleration. Just like points. First point is definition, and the definition is also similarly like a definition of centripetal acceleration, in which only word acceleration is replaced by the force. So write down this definition. The particle performing UCM, means uniform circular motion, is acted upon by an acceleration which is sorry, here acceleration is replaced by a force. So right here is acted upon by a force which is along the radius and directed towards the center of circle, Write down this definition. And directed towards center of a circle is called centripetal force. Is called centripetal force. That is CPF, centripetal force. Now, our next point is the formula. So write down second point. And it is about the formula. So write down this formula. Point is formula. Now, in vector form, FCP bar is equal to minus mr bar omega square, and the negative sign is due to it is taken as a negative. We see this formula in vector form. Now in the scalar form, FCP is equal to mass into acceleration. And we know that as we know three different forms of the centripetal acceleration, therefore the centripetal force is also expressed in three different forms. So write down the centripetal force in three different forms. M v square upon r is equal to m r omega square is equal to m v omega is equal to m v omega. So we completed the second point formula. Now the third point is, it is necessary to maintain UCM. It is necessary to maintain UCM. So let us see first why it is necessary to maintain UCM. We know that, suppose that this is a bob attached to the string, and if the bob performs circular motion or UCM, in this case the force acting along the string is towards the center and along the radius, and so the force along the string is called as a centripetal force, and the bob maintain its UCM until the centripetal force acting along the string is there, or the centripetal force is provided, or until the string breaks. And when the string breaks, the bob will not remain in the circular motion, and it shows that the centripetal force is necessary to maintain the UCM. So this third point is very important. So write down it as a star. The understanding of this point is also important. So I like to explain you with an example. Now the fourth point is, it's an example. Write down, in case of circular motion of earth, in case of circular motion of earth around the sun, in case of the circular motion of the earth, in case of the circular motion of the earth around the sun, write down this example. The required centripetal force, or write down required centripetal force. Required centripetal force is provided. Required centripetal force is provided by the gravitational force of attraction between them. And this example shows that from the necessity of the centripetal force for the circular motion, most famous law of gravitation is made by the understanding of this necessity from the Newton. Now the fifth point is SI unit. Fifth point is SI unit, and it is Newton. So, in the point centripetal force 3.1, we studied the answer of what is a centripetal force in 5 different points. First is definition, second is formula, third is its a necessity, fourth is example, and fifth is SI unit. The next point in the dynamics is the centrifugal force. So write down this is our 3 point, second point. It is also from part first. So write down here 3.2 and part first. Centrifugal force. Centrifugal force. That means centrifugal force. Now, in the similar manner, let us see first why this point arises after the centripetal force. We know that according to the third law of motion, we know that the force always exists in pair, and this is the nature of force. If the first pair is centripetal force, then there is an equal and opposite force, which is called as the centrifugal force. And so this point arises. So write down according to the nature of the force. So write down according to the nature of force. According to the nature of force. According to the nature of force. Nature of force. The force exists in pair. The force always exists. The force always exists in pair. In pair. So there is an equal. So there is an equal and opposite. So there is an equal and opposite. There is an equal and opposite. Equal and opposite force. There is an equal and opposite force, which is a centrifugal force. Which is a centrifugal force. So let us see the question on the centrifugal force. Write down what is a centrifugal force? And the answer of this question is also expressed in terms of a points like a definition, formula, example, unit, etc. So write down the first point. So write down the first point. A definition. And this definition is also similar like a definition of centripetal force. So write down this definition. The particle performing the particle performing UCM. The particle performing UCM is acted upon by a force. Up to this point, this definition is similar. Act upon by a force which is along the radius, which is along the radius and directed away, not towards, and directed away from the center, and directed away from the center of the circle, away from the center of the circle is called centrifugal force. Is called a centrifugal force. Now the next point is second point, and it is the formula. Let us see first in vector form. In vector form, it is F CF bar is equal to m r bar omega square, and write down it is taken as a positive. It is taken as positive, and similarly write down the formula in scalar form. F CF is equal to m r omega square is equal to m v square upon r is equal to m v omega. Similarly, like the centripetal force, the formula for the centrifugal force in scalar form is same because the magnitude is same. Now write down the third point, and we know that this third point is, about the example. So write down third point. Example. We know that in the merry-go-round, the centrifugal force acting on the persons, and it is our common experience that this force acts along the radius and away from the center of the merry-go-round. So take this example for the centrifugal force. Write down in case of merry-go-round. Write down for example, in case of In case of merry-go-round, in case of a merry-go-round, when wheel attains uniform speed, then the centrifugal force becomes equal and opposite to the sum of all real forces, So the equation of the force in this case becomes equation of the force in this case becomes resultant force is equal to m/r omega square minus m/r omega square, or m/r omega square plus summation of real forces is equal to 0. So in this third point we discussed about the example and the equation of the force for the centrifugal force. And the fourth point is it is necessary to use Newton's laws in accelerated frame. Newton's laws in accelerated frame. It is necessary. So in the fourth point we discussed about the necessity of this force. Newton's laws in the accelerated frame. And our fifth point is also SI unit, and it is Newton. Up to this point we discussed about the second point in the dynamics, and it is a centrifugal force in the form of different points such as definition, formula, unit, example, necessity, etc. And the last question of this part, dynamics, is distinguish between centripetal and centrifugal force. So write down this question. Distinguish between centripetal and centrifugal force. Distinguish between centripetal and centrifugal force. This is a last question. So name it as a question. Distinguish between centripetal and centrifugal force. Write down this question first. And then for the answer, for the distinction, draw the table having two columns. Draw this table. First column is centripetal force. Second is centrifugal force. Centripetal force and centrifugal force. Now the first point in the centripetal force is it is a real force. Here write down first point. It is a pseudo force. Second point in the centripetal force is it is along the radius. It is along the radius and directed towards the center of circle. Here the second point is it is along the radius. It is along the radius and directed away from center of circle and directed away from center of the circle. Now here the third point is it is necessary to maintain UCM. It is necessary to maintain UCM. Write down here the third point. It is necessary to apply Newton's laws in accelerated frame. Newton's laws in accelerated frame. And fourth important point or last point it is. It does no work. It does no work because it is perpendicular to the displacement. Here write down, it does work. So, the answer of distinguish between centripetal and centrifugal force is expressed in terms of the fourth points shown in this table. So up to this point we completed the main point, dynamics of the circular motion.